Now, direct variation equations are in the form y equals kx, k can't equal 0. We've already talked about that. The graph of y equals kx always passes through the origin. We've already talked about that. So here's just a visual representation of what two examples can look at. If k is positive, the slope is positive, it's going to be going up. And if the slope is negative, our line is going to be going down. And then whenever we have direct variation, what we say is y varies directly as x. But again, nothing really new on this page, just organized in one simple box for you to refer to. So if we suppose y varies directly as x, right away I know I have direct variation. And y is 72 and x is 8. Well, in order to have direct variation, I know I have y equals k times x. But I don't know what k is. I need to find that. But luckily, they've given me an example of y and x. So what I can do is I can use my equation and I can plug in 72 for y and I can plug in 8 for x and I can solve for k. To get k by itself, I would just divide each side by 8. Now I would get 9 equals k. Now that I know 9 equals k, I can go back to this same equation, y equals k times x, and I can plug in my value for k. So y equals 9x. All I did was I took my example, plugged them in for y and x, and solved for k. Once I knew what k was, I could write my equation. And now that I have this equation, I can use it to find x when y is 63. Well, if y is 63, I know 63 equals 9 times x. Divide each side by 9 to get x by itself. And when x is 7, y is 63. Again, just using our equation, plugging in numbers to find k, and using that equation to find other values.